definition. Can you talk to me a little bit about what a factor is? Start primary and work our way up to maybe what we should know. Yes?
It's something that's multiplied to get what we're looking for. It's one of the, I don't know how to word it, but
I know, it's a hard wording, isn't it? It's a hard way to describe.
Factorial.
It's what?
Factorial.
Well, factorial can be, well, factorial can be like deciphered as exponents and stuff. Yeah.
What it takes to multiply to put it together.
What it takes to multiply to put it together. Sweet. Okay, so if I gave you the number 6, you would tell me its factors are
3, 2, 6, 1.
1, 2, 3, 6. Does that make sense? Like the conceptual idea of it we get. We understand that goes into it, that goes into it, that goes into it, that goes into it. Okay? The conceptual idea we get. It's kind of the abstract idea we have to think. There's one particular concept that I want you to kind of wrap your head around with the word factor. You said it for 6. It's for 6, you told me it is a 1, a 2, a 3, and a 6, correct? And we know that those are the things, right, that are considered factors. Why is number 4 not a factor?
Because it doesn't divide into evenly.
That's what I'm looking for. So, go back and tell me what the definition of a factor is.
Raise hand.
Raise hand.
It goes into something evenly without it being a decimal or fraction. Whole numbers.
It goes into it evenly without it being a decimal answer or a fraction answer to it, right? At the end. So when we look at 1 and 2 and 3 and 6, we know that they all go into the number 6 evenly. We know that 6 divided by 6 is 1. We know that 6 divided by 3 is 2. We know 6 divided by 2 is 3. 6 divided by 1 is 6. We know 2 times 3 is 6. We know 1 times 6 is, you see what I'm saying? The parent thing that we did back in elementary school, the 2's that go together and the division and the multiplication of. So we understand conceptually what factor is. So far so good? So, having said that, when we say it's something that what does what to it? Divides into, and now let's talk more our terminology. We're not talking about a singleton number anymore. We're talking about functions. Okay? We're talking about polynomials. What's a polynomial, by the way? Yeah?
We got multiple parts.
Multiple parts. Poly meaning many parts. Okay? So divides into a polynomial evenly. So far so good? Okay. So I'm going to turn this down because I forgot to do that earlier. This day goes by quicker than you're expecting. Oh, and now it's listening to me talk and it's trying to answer my question. Okay. Okay, so when we divide something into it evenly, so what happens at the end, we have the word old school again. When we divide, we have, if we don't go in evenly, we have what? What's the end? What's
Remainder.
A remainder, right? So what would the remainder be? The remainder would have to be 0 for it to be an actual factor. All right, so far so good? You guys are wrapping your head around it. You know this stuff. We've seen it before, okay? With polynomials, what are the methods that we have utilized to figure, to actually find the factors of a polynomial?
The long division.
Very good. Long division.
And then the other one.
And the other one.
That I don't remember the name of.
Synthetic division.
Synthetic division, that's right.
And it starts with an S.
Okay.
I can't believe it.
What about authentic division?
Yeah, well, I've never heard of that. Like old school?
Yeah.
Like, yeah,
Could we
well.
call it, instead of long division, just be synthetic and authentic?
What you prefer. You can call it whatever you want, but the typical name are long division and synthetic division. Okay, so let's talk about what they are, okay? So, one more thing. This is a method. This is a method. Before I attempt the method, we have a tool at our use that will allow us to show whether something is indeed a factor, okay? Okay, so there's a tool that we can utilize that will help us to figure out if something is indeed a factor, meaning it has a remainder of 0. Okay, so what do you guys know what that is? Do you remember from Algebra 2?
A calculator.
A calculator is beautiful, but not what I'm looking for. Yeah, right. Good. Perfect. It's actually the tool that I'm referring to is what we call the Remainder Theorem.
Oh, that's when if it equals 1 and right? Are we talking about the same thing?
If it equals 1.
Never heard of the Remainder Theorem.
You can guess. It's a theory, so you guess if there's remainder.
It sounds familiar.
You flip
Sounds
the
Yeah,
coin.
it sounds familiar.
See,
You don't flip any coins.
Heads, no remainder, I'm done.
it's when
Please.
the remainder equals something. It's
What should the remainder equal to?
Zero.
Oh, right. So because they want to show that
But
it's a
if it
factor.
equals
Let
1,
me give you one that's equal. That's a good one to do. Okay.
So it's
It's still trying to listen to what I'm saying. How do I stop that?
Turn off there.
That's really funny.
That makes it self-destruct.
Okay. Given a simpleton function, okay, quadratic, doesn't kind of look like it's squared, right? If I'm looking at this, what if I said, I want you to find f of 1?
Raise hand.
Plug in
Yeah,
1,
plug in.
right?
3.
And what do I get when I plug in 1? -3.
Yeah.
The resultant is something other than 0, agreed?
Mhm.
So what happens when I plug in the 2? 2 squared minus 4, 0. 2 is indeed a factor of x squared minus 4. So the remainder theorem says, if the number that you plug in produces an answer of 0, it is,
that's what I was talking about.
that's what you were saying. I know, I heard it. It was a different language. But I heard it. No, I'm kidding. So, does that make sense? So what the remainder says to us is you can kind of check before you start dividing. And that'll come in handy in a second. Yes?
So this could be in any kind of equation of any sort?
Any sort.
As long as it produces a 0?
Correct. It's called the remainder theorem. Okay? So let's go ahead and go through this process with the simpleton x squared minus 4. All right? So I want to kind of go and say, well, let's talk about long division first and foremost. Let's say I want to know if x minus 2 is a factor. We know that, correct?
Mhm.
I mean, just by looking at it, I think you get that. Well, because what is the factors of these? X minus 2, x plus 2?
Difference of 2 squares.
Difference, right. So we know this, but I just want to show you how this works. And when I plug in the number 2, why did I choose 2? Because x equals 2, right? When I plug in the number 2, I get 2 squared minus 4. I know it's a factor. Okay? So now I'm going to show you how long division works. A review for long division. So the first thing we're going to do is we're going to take the divisor, the x minus 2, and we're going to divide it into x squared minus 4. Things to remember. You cannot be lacking of any variable. So if it's squared, you have to have all the descending variables attached to it. For example, x squared, the one right below it would be x, and then the one would be none. So we're missing the one with x, so we have to have a placeholder. Does that sound familiar? Yes.
So we'll always use this for polynomial.
Polynomial.
Okay.
Yeah. Always. Yes.
Did you do x minus 2 because it's a factor now?
I did. I asked.
Okay.
I wanted to show you one that works,
Okay.
and then one that doesn't work. You know what I mean?
Yeah.
So, and we're going to use one that's familiar to us first, so we can see how that works. So we have x squared plus 0x's minus 4. Do you understand what I just did? I have to have all accounted for. Yes.
I don't know what you got.
How do I get this to this? Okay, so x squared. Where's my x? There's no x. It's a trinomial, truly, but it's missing the x. So I put in a placeholder for 0x. Does that make sense? Yes.
I'm just like confused as to why you're dividing it.
Well, because obviously we know it's x minus 2x plus 2. The ones that you're going to get are not one that you can look at. Oh yeah, obviously it's
Is this
okay.
part of the theorem?
Yeah, it's actually doing this part.
You're basically factoring knowing just one of the factors.
Correct. Correct. I gave it to you.
Because you plug in 2 and it comes out to 0, so x minus 2, that binomial's, to get it to equal to 0, you have to plug in 2.
I wanted to show you one that worked and one that won't work. That's not a factor, and what it looks like. Okay, so let's do the process. So the things you look at, there's 2 items. So they have to go into 2 items. Does that make sense what I just said? So I have 2. If I had 3 here, they'd have to go into all 3. So when I have 2 items, my answer will start above the second item because there's 2. So you say to yourself, how many times does x go into x squared?
Twice.
So it's x times, because what times x gives me x squared
Oh,
is really
right.
what you're thinking.
Yeah.
So x. Okay? And it goes above the second place because there's 2 items. And then just like with long division in 4th grade, you multiply each part. So you're going to do x times x is x squared. X times negative 2 would be negative 2x. And what would you do in 4th grade now?
Subtract.
Subtract it out, right? So when I subtract, that means I'm changing all the signs. Would you agree? So it's actually subtracting. So I put a little parenthesis so you see it has to distribute through. So I have x squared minus x squared.
Cancels out.
That's what you want to happen every time. So 0x plus 2x. You with me?
Positive 2x.
So positive 2x. And then I have something that's just hanging, so I bring it down.
Mm-hmm.
So far, so good?
Yeah.
Now, x goes into 2x. How many times?
2.
2.
Positive 2. So in your brain, you're saying, what times x gives me 2x? It's a 2. So positive 2. So that times that would be 2x. That times that would be minus 4. Again, subtract, which means change signs. And what happens?
No remainder.
The remainder is 0. This is indeed a factor. The factors of x squared minus 4 are the original, what we given, and the one we just found. Yes?
So are the questions going to be like they'll give you the f of x
And they'll give you one of the factors.
okay, and it'll
Yeah.
be like, is this
Is it a factor? And how would you show it's a factor? Plug it in and for remainder theorem. Show it's 0. And then actually find the factor. Yeah.
Could you ask, like, if there's what the second factor is, but you're really tricking us because there isn't, so we try to go through that process and
You would do the
find
remainder
out.
theorem first and
Yeah.
say, not a factor.
Mhm.
But they won't trick you on here. They're actually trying to find the factors.
Mhm.
Now, what happens if I had given you this original problem and I said, rather than the x minus 2, what if I was looking for, let's say, x minus 1? We know it's not a factor. Okay? It still is divisible. It'll have a remainder. No different than 5 divided by 2. 5 divided by 2 is what? 2.5? It's not quite a whole number. That's what this is likened to. It's like not quite the whole number. So I'm going to show you how that works. I'm going to have x minus 1, and it's going to go into that x squared plus 0x minus 4. So sometimes life isn't perfect. It's not always a perfect factor. But it's the same process. So let's go through and figure that out. Remember, we had to put our placeholder. That's rather important. A placeholder happens either in here or here, depending on where you're at. Make sure you put placeholders. So I'm going to look at this. I see there's 2 items divided in, so I have to start above the second item. And I say to myself, what times x gives me x squared?
X.
X. Good. So x times x is x squared minus x. Subtract. Everybody cool? So when I subtract down, I get no x squareds, and I get positive x minus 4. Because a negative, negative makes a positive. And then how many times does x go into x?
Once.
Plus 1, right? Positive 1. So I have x minus 1, and if I subtract it down, what do I have left? I have x minus x is 0, and then negative 4 plus that would be negative 3. This is what we call our remainder, but we don't put the big R, negative 3, like we did in 4th grade. You guys know how to work that? You take, yeah?
Take it as a fraction.
You take it as a fraction. You take
Yeah,
this
The big one, whatever.
over the divisor,
The little one?
the little factor. So it's going to be minus, because that's the sign here, 3 over x minus 1. And that is the answer to that. It is not a factor. But I was able to divide it. Are we cool with that? Okay. So, long division, rather cool. Not too hard to work with. Synthetic division, even cooler, if you ask me. No? I think so. Wait till you see it. So, very cool. Okay, rules to synthetic division. Okay? The rules for synthetic division. First and foremost, your divisor, your thing that you're dividing here, this thing, has to be to the first power. That's the only way this will work. If it's quadratic, you cannot use it. You have to use long division. Okay? We'll do one of those as well. So if I'm looking at this and I want to divide, let's go ahead and give me a function. That does not have to be linear. It doesn't have to be, it could be quadratic. Make one up.
X squared
X squared
plus
My-
6x
plus 6x
plus 9.
plus 9. Are we good so far?
Mm-hmm.
Okay, all right. Michael, tell me a divisor, what you want to divide into it.
4.
X, so x minus 4,
Yeah.
x equals 4. Okay. Are we good? Does it work? No, we already tell. How do I know? If I put 4 in here, what I get? Definitely not 0. That's cool,
X plus.
right? We're okay with that. So let me show you how this works. Synthetic division is really cool. You told me 4. I wrote it up as this, right?
Yeah.
It is actually x equals 4, is what he told me, which is perfect because that's where we're going to work with synthetic division. So the way synthetic division works is it's an upside down house, a little different than what we're accustomed to. You take the number that you're going to divide, in this case 4. Okay, what would this number be over here? It would have been a 1. What would this number here be? It would be a 2. You see what I'm doing? I'm setting it equal to 0 and solving. So I'm going to put a 4 out here. And then what I'm going to do is take every coefficient that falls in the quadratic, and I'm going to put them down. If there's something missing, what would I put?
0.
A 0 in its place. So I have in this case, what's the thing in front of x squared?
1.
A 1. What's the thing in front of x?
6.
A 6. What's the thing in front of nothing? Is 9,
9.
right? Are we good so far? What's that?
I remember that.
Now you're starting to remember it. Good, good.
Mm-hmm.
So, first step, make sure your divisor is linear, x to the first, and then make sure you're not forgetting any of the x's in it. Like it could be x to the 4th minus 3. You would be missing a cubed, a squared, an x. You see what I'm saying?
Yeah.
Okay, so step 1 is going ahead and putting your divisor outside as a number, and then putting your coefficients here. Step 1, drop the first number. Just drop it down. So far, so good?
Mm-hmm.
Take this outside thing, multiply it by what you drop down. What do you get?
4.
And you write it right here.
Then you add.
Then you add.
Then 40 plus 9, 49.
So you get, right?
And then you just fill it with
Hmm.
water.
Add them up. Now, we're at the end of the road, right? We can't go any further. I always put a little box here at the end of the road like that. That's where my remainder stays. Right there. So far, so good? Now, let's think logically for a second. When I'm taking x minus 4 and I'm dividing it into x squared, I'm taking it from something that's squared and I'm reducing it by 1 exponential power. Does that make sense what I just said?
Mm-hmm.
So I'm taking this x minus 4 and I'm bringing it in here. What I have left is 1 exponential power less than what I started with. So this represents 1x to the first, because I went from squared down to 1. And then plus 10. And then what was my remainder? 49 over, what was this divisor originally?
X minus 4.
There's your answer.
Miss K?
Yeah.
I thought you said we couldn't use quadratic for the synthetic division.
Inside, yes. Outside, no.
Oh, so it couldn't be x squared minus 4, and that's our
Correct.
fact. Right.
Because then you have multiple
Correct.
factors.
Right. Yes.
Can we do that same one with x plus 1? X
Yes, we
squared?
could do it where it's pretty. Okay? So, yes.
So, what we just did, we were seeing if x minus 4 is a factor.
Yes.
Okay.
We divided it, basically. We found its division. So what, you want to use positive 3?
No, x plus 3.
So at negative 3.
Yeah, negative 3.
So negative 3. Let's see. So we're doing x plus 3. And then negative 3. Okay. So on the outside goes negative 3. So far, so good. And what are my numbers from the inside?
One,
Again,
6.
1, 6, and 9. And I always put my little house down there, show where my remainder would lay, right? Drop down the 1, multiply. Add, right?
Mm-hmm.
Multiply. Add. Oh, that's so cool.
It's a factor.
It's a factor.
That's why I picked that.
That's why you
equation.
picked that. And what is my resultant? X to the first plus 3. Yeah. Does it make sense that x plus 3, which was my original divisor, times x plus 3, which is the one we found, multiplies together to give you that? Yep, that's exactly right. Yes.
So when do you have to use long division and you can't use that?
You have to use long division if the divisor, if this guy that you're trying to divide in
Is squared?
is squared, or
Oh,
cubed,
okay.
or whatever, yeah.
Okay.
Is that good so far?
Okay.
It's really not a bad lesson. Let's go ahead and look at one of your problems, like the first one, for instance. Things to notice, okay? This was, these are exact problems from tests, old tests, okay? Just like before. And this particular problem, I want you to kind of, what are they asking you to do the first part? Show that f of -2 is 0. And without big word, what are they trying to ask you to do without telling you?
Plug it in.
Plug it in.
Yeah.
And it's, what are we basically utilizing? The remainder theorem, right?
Yeah.
We're trying to see whether it's a factor or not. So the first thing we do is we take f of x is equivalent to 12x cubed plus 25x squared minus 4x minus 12, and we want to find f of -2. And we want to show that it's equivalent to 0. So when I plug in -2, I got 12 times -2 cubed plus 25 times -2 squared minus 4 times -2 minus 12. Are we good so far?
Mm-hmm.
Mm-hmm.
Are we comfortable? Yeah. Okay. So 12. What's -2 to the third?
-8.
Good. 25 -2 squared.
4.
And I can actually do these. -4 times -2 plus 8 minus 12.
Mm-hmm.
I'm actually slow multiplying today. You guys are so you're lucky, aren't we? 12 times -8. And then plus 100 plus 8 minus 12. Positive 4 plus 4 is 12. Minus 12 is 0. Check. Done.
So what is this?
worth 1 point?
It is 1 point.
Are we going to talk about?
Factorize, I'm assuming that means break it down, continually dividing.
Exactly. So factorize means factor it completely. They spell it really strange, don't they? So what they want us to do is they want us to factor it completely. We actually know the first factor. Yes?
Yeah.
-2, right?
Yeah.
So,
Is that linear? Absolutely. What's the best method to use?
synthetic.
Synthetic division. So let's do that, okay?
It's quicker.
It is. It's so much nicer. And we'll talk about what factorize means.
When we get it into trinomials, can
Yeah.
we just factor it normally?
Yeah,
Oh yeah, that's why it's to the third.
you can. You can. Sometimes people like to continue with the synthetic because they like it. Well,
But then you gotta figure out
what's
through
the
the remainder
next?
theorem what the next factor
What the next factor is, right? And I can show you a really cool way to figure that out. So let me do that after we factorize, okay? So what do we have for my numbers? We have a 12. Are we missing a square? No. So we're going to put a 25. Are we missing a nope? So we got a -4. Last but not least, a -12. 0. Cubed, squared to the first, and none. I shouldn't have put a 0. I just assumed I would, but you know we should. We just figured that out. Okay? What first?
Drop the 12.
Drop the 12. And
-24.
multiply. Do what now?
Add.
Add
1.
and multiply.
Multiply.
Add and multiply. And add. What do we think? Are we good?
That's what plug again?
We're not done.
Oh,
Why? Because what is this equivalent to now?
oh, it's plug again.
12x squared
plus x.
plus x minus 6.
Right? And what was my original factor?
2, negative 2.
X plus 2.
X plus 2. How many linear factors should I have?
3.
I should have 3
Because there's 3 X's.
because it's x to the third. Now, as you'll learn this year, sometimes those factors turn out to be imaginary. But we'll get there. Yes?
Can you just take 12x squared plus x minus 6 and then factor it out to get 2 pieces?
100%. So you could take it now and do this with it,
Yeah.
right? Or you could continue the process of using synthetic division. Let me show you how you start to guess what the next one would be. It's called P's divided by Q's.
I remember.
Oh.
Okay. Are we good so far? So, how does this work? You're going to take the factors of the last number. So, what are all the things that could go into 6?
3, 2, 6, 1.
Yeah, so plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. So far, so good? What are all the things that can go into 12?
Plus or minus 1,
Yep,
plus or minus 2,
yep,
plus or minus 3,
perfect.
plus or minus 6,
Keep going.
plus or minus 12.
Yep, we forgot a 4, but I
Yeah.
stuck it in there. Yep. I got you back. So, the potential values of the numbers that could go if we were continuing with synthetic division are 1 over 1, negative 1 over 1, 1 over 2, negative 1 over 2, 1 over 3, negative 1 over 3, 1 over 4, etc., 2 over 1, negative 2 over 1, 2 over 2, negative 2 over 2. You get what I'm saying? The potential factors are those. That's so much fun, but we don't want to do that all the time.
A lot of it.
Well, it could be a lot of them. Sometimes it's very minimal because you have a number 1 in the quadratic. But anyway, how does this factor out? Anybody do it?
It's just Barry.
You can Barry method it. What's another way if you're looking at it going, oh, good God, no way? Quadratic equation.
Yeah.
Quadratic.
X equals negative b
So what?
plus or minus.
Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. What does this get me? This gets me the x values that will fill into these spots here.
Mm-hmm.
If indeed there's, it's 3 factors. So what do we got here? Negative 1 plus or minus. So do you guys agree that's 24 times 12? And I'm scared of that. 24 times 12.
Plus 264.
To what?
264.
288.
Yes,
So close. And then it's 1 plus that, right?
Yeah.
So 289?
Yeah.
So what is the square root of 289?
That's a very good question.
It looks like a thing.
It looks
It's
like a thing.
17.
It's a thing.
It's
It's 17.
a thing.
It's a thing. Negative 1 plus or minus
17.
17 over 24. That's a thing.
Mm-hmm.
18 over 20.
So what do we got? We got negative that, so we got 16 24ths,
Mm-hmm.
or negative 18 24ths. What does that reduce to? 16 over 24. 8 goes into both.
2/3.
2/3? Okay, so
And
2/3. So x equals 2/3,
And then negative 3/3.
and then x equals
Negative
negative.
3/4.
And how'd you do that?
It just divided by
By
4.
6.
By 6, right. Good.
Oh, wait.
How do you make that look like that? Yes,
Move it over and set it to 0.
Oh, it's 3x minus 2.
it is.
And then 4x plus 3.
Do you guys see this? How this
Oh, I
works?
love that.
So I take this bottom number first and multiply it up here. So I've got 3x equals 2.
And then,
And then I want to bring it over because I want to set it to 0. So I got 3x minus 2. Same thing goes for this guy. Multiply it over. 4x equals negative 3. Add your 3. 4x plus 3. My factors are 3x minus 2, 4x plus 3. Is that indeed going to work?
Yeah.
So 12x squared plus 9x minus 8x, good. So my linear factorized completely is all three of these.
Miss K?
Yes.
So you could not use synthetic division for the second time because the squared is going to be on the outside, and that's a no-no, right?
Your squared would be on the inside, but you would have to figure out of these umpteen numbers which one would work. And which ones worked? 2/3 and -3/4. What?
Have fun
Good
going
luck
through all
guessing
that
that.
work.
Yeah.
Yeah.
So look, 2/3 is here, and -3/4. But how long would it take you to get to that? Because you would
That's the
you would
next
do
problem.
synthetic division with 1 and
Well-
-1.
Well, see, the
One
thing is
half,
that it's the
negative one.
middle of both of them.
It is. It's
It's the
crazy.
median of both.
I think Berry method, quadratic formula is the way to go.
Way to go.
Yeah.
Yeah. They don't care as long as you factorize it.
Yeah.
So factorize is just means find the factors.
Find the factors. Okay, so are we comfortable? So we did number 1 together. I won't be here tomorrow, but you guys can be working. Oh, let's bring it back. A blast from the past. Ooh. Ooh. Oh, I turned that down.
That's a real block. So you can see it even if it's like.
Yes, right. Very cool, right? Let's look at the very bottom thing, guys. Has only one real root. Does that sound familiar? Has only one real root. It sounds what? Discriminant, right?
B squared minus 4AC
What
equals
should
0.
happen in here if it has only one real root?
The others are imaginary.
Right, the others are imaginary. Right. So keep that in mind. Has only one real root. So what you guys will be capable of starting to work on are numbers 1 through 9. 10 through 14 I will not have taught until Friday. I'll do Friday. But 1 through 9 you should be able to chug along and work on them and, kind of get through that process. I don't know. It's Wednesday.
Oh,
10 or 9.
9, we have.
And remember, right after this, we have a fire drill. Yeah.
Oh, yeah.
Right after
You
second.
gotta go to third period and then,
9.
Yeah, right now it's.
Has our session concluded today?
say it again.
Our session has concluded
We're
today.
done. What do you think? Good lesson?
Yeah.
Yeah.